Hi, this deck of cards was compiled to facilitate working through standalone questions dealing with vector addition. Okay. Show displacement by adding vectors c, f, and negative d. So here goes c, d, but we have to negate, so you would flip the direction upward. And then I said e. I don't know what I said, and this is f. So add them in this order. And remember, when adding vectors, you start with the first one. So you put the arrowhead of the first to the back side of the second. Okay, and so forth. So first you start with C here and put the tip of C to the tail of F. And put the tip of F to the tail of negative D, which was flipped up. And this is the result. But to find the overall displacement for the vector addition, you're going to start at your starting point and draw an arrow to your end point. And this is the overall displacement. Okay. Show displacement by adding vectors A, D, and E. So what's the answer? So you're going to start with A, and you put the tip of A to the tail of D, and you put the tip of D to the tail of E, and then to find your overall displacement, you start at your starting point and draw an arrow towards your end point, and this is the overall displacement. Okay. Show displacement by adding vectors A, negative B, and vector E. I'll give you a few moments to write out your answer. All right, so again, you start with A, and then you connect the tip of vector A to the backside of negative B. And to negate B, all you do is flip the direction of the arrow. Take the tip of negative B and put it to the tail of E. And then this is your final displacement, because you're going to start at your starting point and draw an arrow to your end point. Okay. Show displacement by adding vectors E, negative C, and D. So I'll give you a moment to write out your answer. All right, so you start with E. Okay, it's tilted at a 45-degree angle. Then you connect the tip of E to the tail of negative C, and in order to negate negative C, you just flip the direction. Then you connect the tip of negative C to the tail of D, and you wind up here. And in order to find out your overall displacement, you just start at your starting point and then draw an arrow to your end point. Okay. In a 45, 45, 90 triangle, what is the proportion of the magnitude of the sides? All right, so here goes your 45, 45, 90 triangle. And the legs are equivalent. They have, it's an isosceles. It has, one leg has a value of x, the other leg has a value of x. And then the hypotenuse has a value of x radical 2. So the ratio is 1 corresponding to this leg. 1, because that's 1x. The unwritten coefficient is 1 to radical 2, because the coefficient with the hypotenuse is radical 2. Okay, now that we've been through everything, which of the following combinations will result in the least amount of displacement? Note, vectors A, B, D, and E have magnitudes double that of C and F. So what's the answer? Well, it's going to be this one, the last one that you went through, because when you start at your starting point and connect the dot, well, connect the arrow to the end point, the vector is really tiny. All right, so the vector addition of vector E, negative C plus D yields the tiniest displacement.